Here's one of those questions that almost always pops up in data science interviews. How do you detect and remove outliers in pandas? Outliers might look like just a few unusual points, but they can completely distort your averages, your standard deviation, and even your model accuracy. So let's simplify this. Detecting outliers comes down to three main approaches. 1. Statistical methods. The first one is statistical methods. Here, we rely on mathematical rules to detect extreme values. For example, the interquartile range method identifies values that are too far from the middle 50% that there are similar accuracies of mixed batteries of accuracy and cognitive boundaries. Or you can use the z-score method to find values that are several standard deviations away from the mean. In simple words, if a data point is way off from the typical range, it's probably an outlier. 2. Visual methods. The second one is visual methods. Box plots and scatter plots instantly show you where your data breaks pattern. Those small red dots sitting far away from the main cluster, those are your outliers. Visual checks like this are quick sanity checks before you jump into coding. 3. Domain knowledge. And finally, domain knowledge. Sometimes, an extreme value isn't wrong data. A transaction that's 10 times higher might belong to a VIP customer, not a data entry mistake. So always combine your statistical checks with context. That's what separates the data analyst from a data scientist. All right, now let's see how you'd handle this in Pandas, but I'll explain it in plain English so it's clear and easy to follow. We're starting with the customer transaction dataset. First, we use the interquartile range method. This means we calculate the middle 50% of the data, between the first and third quartile. Then, we find any data points that are far beyond this range, specifically more than 1.5 times the interquartile distance away. Those are marked as outliers, and we remove them to get a cleaner dataset. So, in the code, instead of thinking in symbols, think of it like this. Load the transaction data. Calculate the lower and upper cutoffs based on spread. Keep only the rows that fall between those two limits. And that's it, the dataset is now filtered and clean. Next, there's the z-score method. This one measures how far each value is from the mean. If something is more than 3 standard deviations away, that's a strong signal it's an outlier. We can flag or remove those values depending on the project. So why is all this important in real-world projects? Because outliers can totally mess up your models. Imagine a customer who spends 50 times more than everyone else, where linear regression line would bend toward that one point. By detecting and handling outliers early, you protect your model from bias and make your metrics more trustworthy. It's not just data cleaning, it's about data quality and model stability. So if this question comes up in an interview, here's how I'd answer it confidently. I usually start by visualizing the data using box plots or scatter plots to quickly spot extreme values. Then, I apply statistical methods like interquartile range or z-score to identify and filter them. Finally, I cross-check with domain knowledge before removing anything, because not every outlier is wrong, some are genuinely meaningful. That answer shows your statistical understanding, your practical thinking, and your ability to balance data science with real-world context.